Good day, I'm Sean Young, the welding specialist for Air Products South Africa. I'm here today to talk to you guys with regards to the MIG-MAG welding process. Some people still refer to it as a CO2 welding process, the reason being that CO2 was the first form of shielding gas used in this type of welding process. Today it's known as a MIG-MAG welding process. So MIG standing for inert gases. It's only when we use argon and helium in a mixture will it be referred to as a MIG process, a metal inert gas welding process. The moment we add an active shielding gas to this means either oxygen or CO2 that we add to argon, then it will become a MAG welding process. If we look at the welding process itself, over here we've got a heat source, we've got a shielding gas cylinder, which is connected by a flow meter regulator to the heat source. We've got a welding torch. We've got an earth clamp that's connected to the workbench. So the moment we trigger the welding torch, there's a continuous filler metal that will arc through the electrical current, which will cause the weldment to start happening. And then you will have the weldment of two materials together. We have a voltage adjustment on the machine. The voltage adjustment is there to adjust the weld width. We've got an amperage adjustment on the heat source. The amperage adjustment there is to, the moment I increase the amperage, I'm increasing the welding speed at which I'm welding. There's more filler material that there is, but the amperage is there for penetration. So this all differs with regards to the thickness of the material. Thickness of the material, you're not going to use a low voltage, low amperage settings to weld a 15 millimeter thick plate. You will accommodate it according to your filler material that you are using, either 0.8 millimeters, 0.9 millimeters, 1 mil and 1.2. Then we get to shielding gas. I've explained the types of shielding gases that there are. However, if we look at the MIG-MAG process, it's prone to have porosity. Porosity in the weld means that there's a lack of shielding, number one, or there's too much shielding. That's why we have a flow meter. A flow meter indicates the required flow that you need to protect the weldment from atmospheric contamination, the air that we breathe. We want to keep that out of the weld. We will set on a MIG-MAG process the flow to approximately 15 liters per minute. This will give us a laminar flow of shielding, exerting the shroud on the welding torch to protect the weld bead against atmospheric contamination. We will also use soap water to ensure that the connections are all sound, that there's no leaks. From the regulator here, where the hose that connects to the heat source is fine, on the inside there's a little solenoid on the machine. We'll make sure that there is no leaks there. The reason being that argon attracts the atmospheric air that we breathe, and this causes porosity. We don't want to take the air that we breathe, which contains nitrogen, and contaminate the weld with that. So I'm going to start up the machine, and we're going to do a weldment without shielding gas. And we will see what it looks like with regards to if you have no shielding gas in your weld and what the outcome is of that. As one could see with the practical weldment that we did, you could clearly hear the difference between the two welds. The first one being the one without a shielding gas, which gave you porosity in the weldment, and the second one being with a shielding gas. The second weldment was much more smoother, although you could see that the expulsion from weld metal from the weld pool, the splatter volume, or as people will refer to it, the volcano effect that took place, that was due to the carbon dioxide disassociating in the arc. So the more CO2 you have, the more of that volcano you will have, the more splatter you will have. I hope this has been a very informative session. Please feel free to contact Air Products should you have any technical queries. We'll gladly assist where we can.